Hello, I'm Nirmali Samarakoon. And to be honest, I went to several schools, so I'll just mention the school that I did my A levels in. I did my A levels at Visaka Vidyalaya, Colombo, and after A levels in the bioscience stream, I got selected to the Faculty of Science. And then in my third year, I specialized in immunology and integrative molecular biology. And currently, I'm working as a teaching assistant, or we say a temporary demonstrator, for the third and fourth year special student in the streams of zoology and IIMB. Well, for my research, I did under the topic serum levels of cytokines and vitamin D as potential prognostic markers of acute ischemic stroke. So one thing special about the Department of Zoology and Environment Science is when you are supposed to do your research, you will be given the freedom to select whatever the research topic that you want that aligns with your specialty. So, since I did IIMB, there are two main streams that I could go into. Either I could focus on immunology or molecular biology, or it could even be a collaboration of the two. So, I was more passionate about immunology. Therefore, I wanted to pursue my research in that is heavily relied on immunology. So, to be honest, I did not have a particular finer area or a very narrowed down area in mind. I just wanted to do an immunology research. So with that in mind, I met with my supervisor, the senior professor Preeti Udanama, and along with madam's help, I developed my project. So she was the one who guided me to do a topic in neuroimmunology, and along with my co-supervisor, Professor Tashi Chang from the Faculty of Medicine. So at first, I read up on different areas, the current research topics in neuroimmunology, and came up with a research idea on Alzheimer's disease. But it was rejected since that area was a bit redundant and we were supposed to do something new, something that actually fills a research gap, which would be beneficial for me academically. So, therefore, I had to dig a little bit deeper and find something else. So, I read more on the research trends in neuroimmunology and came up with this project that I finally decided to work on. And then, along with my two supervisors, I was able to fine tune it and then come to this topic. To briefly introduce my research, since it was focused on developing a prognostic mark panel, what we focused on was the outcome of patients because normally clinicians, it's easier for them if they could design the treatment regimen based on the prognosis, because once a patient is admitted to the hospital, a patient with a stroke is admitted to the hospital, a clinician would not have an idea on what the outcome of the patient is going to be, whether it's going to be a good outcome or whether it's going to be a bad outcome. So if we have a prognostic marker panel, it would be easier for them to monitor the fluctuations in the parameters that are given in the panel and then come to a decision. So that will help them to fine tune the treatment regimen, the rehabilitation process of a patient. So that was the main objective of this research. And focusing on that objective, we came up with a plan and developed the project. So that is the basic idea that we focused on. So since I recruited patients, I had to first of all get ethical approval from an ethics review committee. And for that, I submitted an application and a whole set of documents that contains an information sheet, consent forms, and other supplementary documents, along with the project proposal to the Ethics Review Committee of the Faculty of Graduate Studies in the University of Colombo. And we were able to get ethical approval for the project. And then, based on the different exclusion and inclusion criteria, I was able to recruit patients from the National Hospital of Sri Lanka. And with the help of the trained staff there, I collected blood samples and separated out the serum in our labs and stored them. So for the assays, for the cytokine assays, I used sandwich ELISAs. And for the vitamin D assay, I used a single use vitamin D competitive ELISA. So all of these laboratory work was conducted in the combinatorial research laboratory of our department. And then I selected patients based on the different test groups. So there were four test groups that were depending on the time of admission to the hospital after stroke onset. That is less than 6 hours, 6 to 24 hours, 24 to 48, and 48 to 96 hours after stroke onset. And then I had a control group that consisted of healthy individuals. So, and we calculated the sample size accordingly, but the sample size had to be limited because of the limited resources that we had at that time. And so I had 15 members in each group, and so a total of 60 members in the four test groups combined and 15 controls, so making a total of 75 individuals that were recruited for this study. And so after all that, after the blood was collected, they were assayed for the cytokine levels and the vitamin D levels in both the test and the control groups. And then we plotted graphs, came up with a cutoff line, and checked the fluctuation, whether the levels of cytokines have increased, decreased, and the patterns of the increase and decrease. And the data was analyzed statistically. And then we came up with the conclusions. So in my project, we were able to develop a biomarker panel, a prognostic biomarker panel that consisted of IL-4, IFN gamma, and vitamin D. And that came up with an accuracy of 99%, a sensitivity of 96%, and a specificity of 98%. So, and also I checked the fluctuations, the impacts of these different markers on the outcome, on the good and the poor outcome. So we were able to see a very clear change in the levels of cytokines. So I analyzed three cytokines: IL-1 beta, IFN gamma, and IL-4. So where IL-1 beta and IFN gamma are pro-inflammatory cytokines, and IL-4 is an anti-inflammatory cytokine. So there was a very, very clear change. In the pro-inflammatory cytokines were clearly increased during the initial stages of inflammation after stroke onset, whereas the anti-inflammatory cytokines were clearly increased during the recovery stage of stroke. And the vitamin D levels, interestingly, or majority of the population had lower vitamin D levels than the expected normal level for sufficiency. And that was in par with the findings so far, because it has been found out that majority of Sri Lankans, that is statistically speaking, 92% of Sri Lankans are deficient in vitamin D. So my findings were in par with that. And the other interesting conclusion is that we were able to find out that vitamin D very strongly correlates with a good and a poor outcome. So most of the patients who had a good outcome had comparatively higher levels of vitamin D in the serum compared to those that were deficient in vitamin D. Most of the patients who were vitamin D deficient ended up with a poor outcome in stroke. And in conclusion, so we were able to develop a very good biomarker panel, and I told, like I said, with very high accuracy, sensitivity, and specificity. The other thing is we came to a conclusion that vitamin D supplementation could be used as a method to improve the prognosis of stroke patients. And I have to mention that this is the first study that was conducted in Sri Lanka that studied the immunology of stroke, and developed such a prognostic biomarker panel. As I mentioned earlier, when I discussed about the research findings and conclusions, this is the first time such a study has been done in Sri Lanka. And I believe that if we were to disseminate the findings, we can sort of, you know, support the clinicians and the patients, particularly in the process of recovery after stroke. Particularly if we can supplement with them with vitamins such as vitamin D, then I believe that we could improve the overall prognosis of stroke patients in Sri Lanka. Um, well, regarding continuation of this project, I'm done with I've completed all the laboratory work related to this project, and then we, with the help of Janit Veeraman in the plant science department, he's an assistant lecturer there. He's also from our batch. Uh, we were able to develop a statistical model to validate the results that we obtained, and we came up with a very nice model for that, which we are hoping to publish in the coming future. Well, one of the major obstacles that I had to face during my research was COVID. So we had to limit the number of members that came to the department, that came to the lab. All the members in the lab could not come on the same day. So we had to plan and we had to schedule our work accordingly. So as soon as we were like sort of getting used to it and arranging our schedules accordingly, we started facing the economic crisis, and that was one of the most harsh periods during the research, because there was no funding available. No, particularly the vitamin D kits, they're extremely expensive. When I requested a quotation back in January, the price was 98,000 Sri Lankan rupees. But by the time I was going to order it, it came up to 4 lakhs 98,000. So that was nearly 5 lakhs. So we had limited funding, and we had to pool all the money and look for sponsors, look for places that we could maybe purchase it at a lower cost. So it was a whole lot of uh, let's extra stress that was added, lack of funding. And the other one was the during the economic crisis days. I hope you all remember, we had long power cuts that went for 15 and 16 hours. So we had to schedule our work accordingly, sometimes optimize the protocols accordingly. Like imagine I had to do ELISAs. So some of y'all might know that it takes about 8 hours to do an ELISA. So imagine you spend 8 hours of your day doing that. And at the moment you're about to take the results, the power goes off. It has happened to me, and it's extremely frustrating, and it's going to be a way it was a waste of an entire day at times like that. So we had to plan accordingly. We had to check the schedules, we had to optimize the protocols and do everything. We had to work around that. We had that those two are some of the like major obstacles that I had to face during my project. And the other one, sample collection, I had to do that amidst COVID. So I was not allowed to visit most of the wards because they were restricted areas. And I had to go to all the wards, look for patients, and extremely tiring. So that was one of not really an obstacle, I would say, but that was a time that was not very easy for me, since I also fell sick during those days. So, those are some of the major impactful obstacles that I remember. I did really gain a lot from my research. Apart from the lab experience, I developed a lot of soft skills. And so, listing them out, so I learned how to work in a lab, how to work as a team, how to coordinate with my supervisors, how to come up with a research plan, a research proposal, how to carry out everything, all the to check off all the tasks that I was supposed to do. And apart from the skills that I gained, like ELISAs and statistical analysis, apart from all that, what I value most are the soft skills that I learned, particularly how to work in a lab, and also how to talk with sponsors, how to talk with different, how to interact and coordinate with different personnel that we meet along the way at different stages of the project, and how to develop contacts, how to network. So those are some of the most important and some of the most valuable skills that I gained during my research. And I hope to improve myself as a researcher, to gain more skills, to um, and maybe apply them in future, and do something for the betterment of the country and the department, at least the department, then I would be happy. So, one of the best advices that I received from my supervisor was to plan things. And that is the same advice I would give for young researchers, junior researchers who will start their research in the coming future, and in many more years to come, is to plan your work. By that, I don't necessarily mean your workflow. Plan your workflow, your timing, and the resources. Let's say, if you are thinking of some experimental procedure, think about the protocols, think about the reagents, and where you're going to conduct it, when you're going to conduct it, basically everything. Just have a picture of what you want to do, what you want to achieve, and where you want to be at the end of this period, at the end of the research period. And just try to fit your work into that frame, but it doesn't have to be a tight knit thing, can be flexible, but just try to have a plan on what you're going to do. That is the best advice I can give you. The other thing is, wa- select something that you like to do, something that you would enjoy doing. Just don't do your research project for the sake of doing a research project. Try to enjoy it, because research can be physically and mentally exhausting. So that you will not really want to pursue something that you don't like in such stressful conditions. If you actually enjoy doing that, being tired mentally and physically won't be a huge issue, because you're passionate about what you do. That is also something what my supervisor told me. She told not only me, what she always tells is to be passionate about what you do, about what you learn. So be passionate. And the other thing, final thing I want to say is, after you finish your research project, the 8 credit project that you're supposed to do, just don't give up on research. Try to develop your skills. Try to gain more experience. Try to volunteer somewhere. Even in the labs that are in the university, you can talk to the PhD students or the postdoctoral students or the master students, whoever, while they are in the lab, the research assistants and everyone. So you can get involved in projects and try to expand your skill set beyond what you gain from your research.